This is the afternoon lab activity on May 24, which is our third lab. And you're given a sphere, and this sphere is internally pressurized. The dimensions are given there. And you're asked to basically run it and find out what the stress distribution is in this spherical pressure vessel. Now, there are analytical formulas from elementary strength of material courses and or deformable bodies courses, and it's given as PR over 2T. And of course, the stress through the thickness direction is zero. And you're asked to use the most appropriate elements, so you should be using shell element. Do not use solid elements. Most appropriate element is shell element. And you're asked to use a 45-degree sector to model this piece only. Okay. So the radius of the shell is 40. It's made out of steel, and what is the thickness is 0.1. So let's go ahead and do the problem. Uh, the way I'm going to do that is generate that surface directly. So let's start with the part file. Instead of making a solid object and then extracting the surfaces and things like that, on that vertical plane, I will sketch. Okay, why don't I do a quarter of a circle? Here's the center, like that. Okay, and the dimension of this is 40 inches. 40 inches. Okay, fit it so that we can see it. Where's the fit? Right there. Excellent. Now exit, and revolve it about the z-axis by 40 degrees. There. So this is that drawing that you see, that figure that you see here. Okay. Now notice first of all that this original quarter of a circle that I drew is actually in the global YZ plane. That's great. But the other one on the other side is not in either YZ or XZ or XY. So I need to create a coordinate system. Here's what I'm going to do. And there are many ways of doing this thing, but here is what I'm going to do. Here is the axis system. And I can do it up there, or I can do it for simplicity so that I can see it better down here. The origin is over there, and I want to rotate this thing by 45 degrees so that this edge back there will lie in the YZ plane. So put the cursor in the third, see that Z-axis box? Right-click rotation, and you put down 45 degrees. And what happens is that that coordinate system at the bottom is rotated, you can see that, rotated by 45 degrees, and that edge now in the YZ lies in the YZ plane of this coordinate system. Okay, let's apply material to this thing. It's made out of steel. On that, you say okay, very good. And that's pretty much it. Or you're asked to, although you're not asked to do it in the advanced machine tool, but that's what I'm going to do. So I'm going to go to Start, Analysis and Simulation, Advanced Meshing Tools, and here is the surface mesher. See that? I click on it. Let me put down here maybe 0.5 and see how it looks like. Say okay, and make sure you click on this icon under execution. Click on this icon so that it meshes it. And this is about 4,000 elements. Okay, 4,000 elements. Wow. We'll see. Exit. Now, the rest of the problem has to be done in the generative structure analysis. In other words, the restraint and the loads and things like that. You cannot do it here. This is called advanced meshing tool. That's what it does. It creates a fancy mesh. So we switch workbenches here. We go to the analysis and simulation, generative structure analysis. let's look at our mesh because I have a suspicion that's going to be very fine. Right click, mesh visualization, and change the rendering. Oh my God, look at that. I don't want that. I don't want that. Double click on this, change this thing to maybe 1, maybe 1.5. Let's see how it looks like. Say okay. That's fine. Mesh it again. That's more civilized. You say okay and exit. Good. Now we go back to, if you display our mesh, it's a lot more manageable. There we are. Notice that we didn't have to do that. We could have meshed it here in the generative structure analysis with the 3 noded elements, but I wanted to show you that uh, how it's done in the advanced meshing tool. By the way, the activity for the morning, I specifically said use advanced meshing tool. I didn't do it here, but anyway, I just showed you how. Deactivate this, do the rest of the problem. Now, let's start with, oh, you know what? When I went, just watch, when I went to the advanced meshing tool, it gave me the opportunity to select whether I want to do static or dynamic, etc. analysis. I must have not picked properly, or I lost it. See, I don't see any static analysis here. Now that can be done. Look. You go to insert static case right there. Okay? And this is where the restraints come and things like that. But you know what? I'm going to kill this. Go back here and do it again. What do I mean by that? So you go to Start, Analysis and Simulation, Advanced Meshing Tool. You see right there, it says, what do you want? Static analysis. And this is where I get static case. I didn't get it last time, so I had to go manually insert it. But that's okay. So here's the surface measure. On that, I use the same numbers that I had. You say okay. You mesh it, and then you say okay, and exit. Excellent. And now we're going to go to the generative structure analysis. There we are. See, we have the static case there. All right, good. So this edge lies in the YZ plane. So user defined restraint. The problem is that it won't let me pick that edge. That's because there's a sketch sitting here. Remember I drew quarter circle? That sketch is blocking me. So I'm going to hide that. Just like the point, you should not put it on points. Hide it. And now for the support, I can select this edge. And this lies in the global YZ plane. Therefore, there is no displacement in X, and rotation is exactly the opposite. Okay, excellent. Now do it again. And by the way, what I'm going to do is I'm going to name this so that you can identify what you did. I'll call it global YZ symmetry. How about that? Global YZ symmetry. In case you ever have to look at this, you know what these things are. Good, right there. See that? Now another one, you click on this, uncheck all of these, you select that support meaning that edge, and not in the global, but in the user coordinate system, it says, which one? Where is it? Well, it's right here. Okay. And this edge that I showed you lies in the user coordinate system, also YZ plane. So no displacement in X, rotations opposite. And I'm going to call this thing user YZ symmetry. Okay, very good. Now this bottom edge lies in the global XY. See that? Global XY. So another one, I say global coordinate system, XY symmetry. So what do we know? If it's in XY, first of all, and it's a global coordinate system, let's change this thing to global. Let's change to global. It's in the XY plane, so it does not move in the direction Z, and rotations are exactly opposite. Very good. Oh, and the support, of course, is this bottom edge right there. And then we say, okay, very good. And the load is pressure. So here's the pressure on that face, 100 psi. This is the wrong direction. So minus 100 psi. And then we say, okay. You can see that now it's pressurized from inside. And then we're going to run it. Oh, thickness. Let me try to run it to show you what error message you're going to get. It says, wait a minute. I don't have the property because I didn't do it. So you go to 2D property right there. You select that. And I think the thickness of that was 0.1. The reason it already knows 0.1 is because in the morning when I did the other section, the activity for the other section, it was also 0.1. So I put a 0.1 here, it knows. Good. Now we run it. There is no problem. Basically, this is going to inflate, right? Nothing fancy is going to happen. It's going to inflate. So if we got the, for example, the deformation, there we are, and you animate it. Okay, the only thing that I don't like is I don't like the way it is on this side. Okay, so let's go make sure that we didn't make a mistake, or I didn't make any mistake. So deactivate that. Okay. It's this condition that I don't like. I don't know by how much I rotated that. Did I rotate this thing by 45 degrees? I'm not sure. Let me go here, double click on it. Oh, that was 40 degrees. That's what I rotated the coordinate system by 45, whereas I took a 40-degree sector. This should be 45. Very good. Now we go back and run it. It's going to be exactly like we expect. Okay, so let's try to run it now. You know what happened? I created the geometry by revolving by 40 degrees, but the coordinate system that I wanted to uh, create here was done rotated by 45 degrees. Now, when I plot this, it better be perfectly, what do you call, perfectly inflating. Okay, so let's go here. There we are. That's what happened. All right, folks, and you can plot the stresses here. If you look at the principal stresses, if you zoom in, you know what's happened. This is one of them is both of them are PR over 2T. In fact, if you zoom in and you put the cursor on any one of these, they must be almost the same number, and they are, because it's got to be both of them have to be PR over 2T. And if you put the P 100 or 40 divided by 2T, you're going to get this number. All right, folks. Good luck.